On today's Visual Studio Toolbox, we're going to continue our look at machine learning. Veronika is going to show us how easy it is to create and use a model inside Visual Studio. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and today we are continuing our discussion of ML.NET. This is part 2 of a 3-part series featuring Veronika Kolesnikova. There she is. Hey, Veronika.
Hi, Robert. Good to see you.
Good to see you again. So in the previous episode, we did kind of a high-level overview. We didn't really get into Visual Studio yet, but I think it was very good to kind of set the stage. What is machine learning? Where does it fit into artificial intelligence? And then today, we're ready to dive in, fire up Visual Studio, and start building a model and then seeing how we can use it, right?
Yeah, that's right.
Okay.
Okay, so let me share my screen and show my Visual Studio 2022.
And which Visual Studio is this? Is this the old Visual Studio 2019 or the brand new, just released Visual Studio 2022?
That's the brand new Visual Studio 2022.
Good answer.
Yeah, I've been using the old one and new one in parallel for some time, but now I fully switched to 2022.
Excellent.
So here I want to create just a simple empty console application. So that create a new project window, I'm choosing just a console app. I have a bunch of them, so it's number 2. I'm using C# here, and I'm creating a new solution. You can always name it something more meaningful. I think I'll just keep it as console app 2.
Excellent.
And then here you can choose framework. I'm sure developers have seen, .NET developers have seen that window, and they can choose the right .NET version that they prefer. I will
learn all about .NET 6. They can go back and watch .NET Conf, which was a couple weeks ago, where it was talked about in great detail.
Exactly. I will choose .NET 6 and create a new app. It is empty, doesn't have anything, just hello world.
So a little bit of, we actually recorded this before the launch, so that's why yours says preview and it says watch the .NET launch on November 8th, which by the time we publish this will have already happened. Not that anybody is surprised that when we record an episode ahead of time, we actually did it ahead of time.
Yeah, so maybe we can cut out that yellow notification, but then it still says preview here.
Leave it in. All right.
Okay. So you can see in the Solution Explorer, it's empty console app, doesn't have anything other than program CS file. And now I'll be adding machine learning magic here. So you can click on add and then add machine learning model.
Now, did you have to select a particular workload or add a specific component to get that, or does it come by default?
So ML.NET Model Builder is available inside Visual Studio. You just need to make sure that when you are installing it, this component is checked.
Okay.
Or if you install.
Yeah, so it's not a workload, it's one of the components.
Yes.
Okay.
Or you can install it later if for some reason it's not there. You can always go back and add it to your installation.
All right.
So here, when we are adding that ML.NET Model Builder, we are able to change the name. I'm not going to change the name, just leave it by default since it's not the main goal of this demo. But when you're working with production code, working on your client project, definitely don't forget to update the names.
Okay.
So it just takes a couple of seconds, and then you can see that beautiful UI that is ML.NET Model Builder. You can see the scenarios available, data classification, value prediction, and limited scenarios that I mentioned in our previous episode, like anomaly detection, forecasting, and clustering. Also, I want you to pay attention to those little labels here. So it says local for some of them, and then Azure and local. And for example, for image classification, you might not have enough compute power on your local machine in order to perform that kind of model training and model creation. So if that's the case, then you can always connect to Azure and use all that Azure magic.
Okay.
But today I want to start with the most basic, in my opinion, scenario. It is widely used in all kinds of applications. So I'll start with data classification.
So this would be a good place for people new to this to start out and learn how this stuff works, right?
Yes.
Okay.
And you can use your local processor, the memory you have. You don't need to connect to Azure. You'll be using just text data. So nothing too complex there, or no heavy data is involved usually. And before moving forward, you can see on that screen that it shows my local CPU environment, just to make sure that that is working correctly, that I have enough compute power to actually move forward with that scenario. And then for next step, I have two options here: connect to a file uploaded here, or connect to SQL Server. I have all the data inside a TSV file. So let me actually find it. I have a couple of options available. I just want to use an option with less data, so it is not taking too long.
And did you create that data? Is it from a sample?
Yeah, it's a sample data.
Okay.
You can find it on GitHub. There are also lots of third-party tools and data sets that are available. So I chose that Wikipedia detox file with only 250 lines. That is not enough for a production model, but for demo purposes, that's good enough. I will run through it faster. We'll save a little bit of time. And I got that data from GitHub. But there are also online portals with data sets. So you have lots of options for demo purposes. And here you can see data preview, what's happening in the data set. It's not going to show you the whole data set, obviously, because it might be too long, but just 10 rows out of 250. And then here we need to choose column to predict, and we'll be predicting sentiment. So based on the text, we are trying to figure out if it's a root comment or a non-root comment, non-toxic comment. And also you have that advanced data option. So if you have, I have only 2 columns here in the data set, but if you have more, then you can pick and choose what columns you're going to use, and other data options that might be needed before that actual training. And now we need to move to next step, and next step is training. And here is that tricky part where you need to choose how many seconds you want to train it. Out of the box, and by default, it kind of tries to estimate the amount of time you might need, but also they have that link to documentation, so you can read more about training time and figure out what is better for your data set. And here I can start the training, and in the output window, I see what's happening there. It actually checks different model types and tries to figure out the best. And the best model that was selected is that model here. I'm not going to try to pronounce it. But you can read, again, you can read a lot about types of models for all kinds of data in the documentation. And you can see that actually went only through 2 types because we had only 10 seconds. But usually if you have more time to train it, then it will go through more types of models and pick the best one for your data. Also, a good thing that you can see here on the screen is the accuracy. So you can see that the accuracy is pretty low. I wouldn't recommend using the model with that kind of accuracy unless you build in something not important at all.
Would that go up if you trained it for longer?
So that's a good question.
I guess it kind of depends on the data, right?
It depends on the data. We can definitely try to train it longer and just check if the accuracy increases. It might increase a little bit. And I'm just saying that based on my experience, but it's not going to increase a lot because of pretty small data set.
Right.
And then you can see the same output, but now because we have more time, it went through 3 types.
Okay. Interesting.
And yes, it increased a little bit. But still not production grade accuracy.
Right.
But that's okay. We are using it just for demo purposes. So I'm gonna go to next step. And next step is evaluation. Here by default, it's just picking up the first row and it gets that sentiment text from there. Ideally, in real world case, I wouldn't recommend just using the first row. Usually what data scientists do, they split the data set into 2 parts. One they're using for building a model, and the second one they're using for evaluation. or you need to have at least a couple of options for evaluations that were not part of that training data set.
Okay.
But here I'm going to use just the default option. Click on predict. It is toxic. It's pretty sure 99%. So that's pretty good. We can move to next step. And next step is consume. There are really good options here. If you already have your application built up and you're just waiting for that machine learning part, then you can just copy that snippet that they are providing and start using the model. But if you want to play a little more with the model, see how it works, see a good example of usage, and you don't mind creating a separate app that you will delete later, most likely, then you can just add a console app or web API.
Mm-hmm.
I'm going to use the console app here. And again, you can rename it here. I'm not going to do that. So here you are getting basically the whole console app, which is connected to ML.NET model. It is already using it, so you can just run that console application and see how it actually worked. Let's go here. I'm gonna close that and this part too. So you can see in the program file, it is automatically passing that first line. So whatever we did during that evaluation step, it is trying to do the same thing here. It is using the text to predict and passing it to the model, then some write lines in the console. So they are helping to understand what's happening there. It provides them sentiment, also repeats the sentiment text, and then provides the prediction. So we can, it's a good way to understand how you can use the model. But you definitely don't have to include a console application in your solution. If you know what you're doing, you just grabbing that snippet that was there and then connecting to the ML.NET model. The model itself is here, so it's here, and then it's that ML model 1.zip. You can see it in both applications. And yeah, I think I can just run it and make sure it is working.
So we basically created a model, and then we're using that model in a couple lines of code, and we're just passing in some text, which could be read from a file or picked off a entry in a form or on the screen, and then we're applying it against the model and coming back and saying, that's rude. That's it? It's that easy?
Yeah, that's it.
Oh, that's amazing. So then, of course, all the difficulty comes in, obviously, the data set, and then somebody ahead of time needed to decide for all of this what is a rude statement, what's not a rude statement, what the values are, right? So the initial data set, initially this might be a manual process, right? Somebody just has a quick screen, brings all the comments, and they say negative, positive, neutral, right? and then just go through that. And eventually you'd have enough of that data in there to create a model, to create an accurate model. You can create a model from any amount of data, but the more data you have and the more good data you have, the better your model. So then you replace that manual process with your ML model, review it to keep training the data and training the model. And eventually, whether it's a week, a month, a year, who knows, hopefully sooner rather than later, you'd have a model that's good enough that you don't need to do that manual process anymore. You'd probably just, on a regular basis, check it to keep training up the model, but eventually you've automated this process, right?
Yeah, and you need to keep logs. As for any kind of software, for machine learning, you need to have the logs to make sure that the predictions are accurate.
Right.
Maybe user feedback. If you are especially building bots, then usually people need to have that opportunity to complain, or maybe say that something didn't work correctly, and then you are keeping those logs. They can be automated. They don't have to manually type anything. But based on those logs, you can actually provide more data and retrain your model with that new data and make it more accurate and just overall better.
Cool. So that's basically all it takes to get started doing this with a very simple model, very simple scenario. But the key takeaway is that model builder, which is part of Visual Studio, you just have to make sure it gets installed. There's an amazing amount of power in it. And of course, it gets better and better and better as the team behind it, who knows an awful lot about this subject, continues to improve it, right?
Yeah. I noticed I started using the model builder maybe just as they released it a couple of years ago, and I can see big changes. It definitely gets more convenient, better, faster, more convenient to use, and I'm really impressed with the work that ML.NET team is putting on.
So what are some of the other basic scenarios that people could look into or that you've seen? So here we just did sentiment analysis. I know we've seen image classification. Is this a dog? Is this a cat? You know, what type of car is this? But what are some of the other things that you've seen people be pretty successful with?
I think all scenarios, they are definitely popular. That's why they decided to include them all here. Value prediction is popular. You can predict value of your house if you are trying to sell your house or maybe buy a house. Data classification is simple and powerful, and it is easy to set up. Same thing with image classification. And there are lots of tools that are available, so you can mix and match. Maybe you are creating some parts using the model builder, and then you can add like maybe cognitive services on top of it, doing like speech recognition or something like that.
Okay, cool. So if you wanted to do something with image classification, you just need to know what the categories are ahead of time, and then have enough images and identify that this type of image is this category. And the more images you have to ahead of time to go into each category, the better job the model would be able to do to figure things out, right?
Yes.
And then it's just a question of constantly monitoring how good your data is and how good your model is, right? And your model is only going to be as good as the data you put into it. So it kind of becomes this feedback loop of my model's no good. That's because my data is no good. So you got to get better data, which leads to a better model, which leads to better data, leads to a better model. And you get this virtuous cycle, I would imagine.
Yeah, data is constantly changing, so you need to make sure that you're staying up to date.
Yep. Cool. All right. This would be a good place to wrap up this episode. And what are we going to see next week?
Next week, we'll see more advanced scenario. I want to show image classification.
Okay. Cool. All right. So hope you join us for that. We will see you next time on Visual Studio Toolbox.